First of all, LiDAR is available. It hadn't been up to a few years ago. LiDAR software, LiDAR data is very dense. Let's take a look at one here. So I'm going to open for you a LiDAR data set, which it comes with all kinds of different data points. Okay, here's my LiDAR examples. So software can read all kinds of different file formats. We can read LiDAR in the LAS format, which is what I'm going to show you. We can also read ASCII data, and LiDAR often comes in an ASCII file. I've just seen a LiDAR file that was packaged up as a DEM. So LiDAR can come in various formats. In all cases, let's just take a look at one of these LiDAR files here. In all cases, the LiDAR has the option of containing multiple different kinds of data points. So here we've got ground data points tagged as 2, and then there's unclassified, low noise, water. You'll often see classifications like foliage or high foliage, low foliage. If I bring in all the points, we've got way too many for the software. If I bring in the ground points, no problem at all. There's only 1.4 million here. So I'm just going to bring that in quickly, and you'll see what that looks like. I'm not going to bother doing a selection. Also, I only need to tell our software that it's meters. But often you're working in real coordinate systems, and you want to make sure that you can do things like export to Google Earth. And so you want to set up a correct projection, whether it's UTM or BCL bears or state plane or whatever. We're going to work in that undefined at this point. So it's reading a large number of points here, 1.5 million. Doesn't take very long, and doesn't look like much until you actually put a tin surface on it. So let's just do a tin surface here. And I'm going to put on contours 50 and 5. That sounds reasonable. Let's not bother with labels. Now, this is just one little tile. And generally, LiDAR comes in tiles. They're rectangular that have been created for you for convenience. And this tile contains 1.5 million points. If I had 50 tiles, I would have trouble doing this. So there it is. Looks good. Let's see what it looks like in 3D. So to create a 3D view, it takes a little bit of time because there are so many points, but it's quite capable, terrain's quite capable of doing that. Sorry, I'm jumping around a little bit here. You can see what that surface looks like in 3D. On my screen, it reacts quite quickly. Of course, we are working over the internet here, so there's a bit of a delay. So if I rotate the screen, it takes a little while before you see the results. Anyway, there you go. You can see the LiDAR is accurate enough so that I can see existing roads on the ground here. There's clearly an existing road where my mouse is tracing there. And we've got the contour lines displayed on there. I calculated those. Now, let's look at a more realistic problem. I'm going to start from opening up a file that contains some initial road data. There it is. Now I wanted, this is an area of interest. I drew this. This is just a line here. And draw it again just to illustrate. You could make any polygon on your terrain and call it an area of interest. In addition, there's an existing alignment in here. I could have imported that from Shape. I could have imported it from Autodesk, AutoCAD, any kind of two-dimensional line that represents a road. We can import that into our terrain module. So file insert, and you can choose all the various different things that we read, including shapefiles, ASCII text, of course, surveys. If you're working in the forest, you might have some TR1 files, soft tree traverse format, and DWG, and all kinds of other formats. I'm mentioning this because these lines or corridors can be very valuable in bringing in your LiDAR data. So here's a feature that I just drew with the mouse. I can move that around a little bit if I want to change its shape. And it happens to be called AOI. I named it Area of Interest. And if I wanted to create another one, I would probably do this, say File. Oh, maybe I don't know where I want to draw, so maybe I'll put in a background here first. Let's add a air photo background that I have. Now it's not a particularly exciting air photo because I just stole it from Google Earth. There it is. So let's say I wanted to include this particular rectangle in my area of interest. I could just create a feature. Let's call this AOI2. Draw with mouse. Click to create a point. Click again to create another point. So it's click again to anchor. Click a second time to anchor. And then I'm going to close it. Okay, so there, I've created a rectangle. Now I'm going to use this information to read in my LiDAR in those areas of interest. So this is kind of key. LiDAR files are really big. If I go File, Open, or File, Insert File in this case, and choose 15 LiDAR tiles, there's going to be a lot more than 1 million points. Good rule of thumb, terrain and location can handle 5 million points. So I only have 2 LAS files here, but I could have lots and lots of them. Watch what happens when I open more than one. I get a chance. It does take a little while. You'll need some patience if you have 15 or 20 of these things. It does take a little while to examine an LAS file. I'm not quite sure why. We're looking into it. There we go. So again, I only want the ground points. Now I'm in the Selection tab. So I'm importing LiDAR. My default selection says read them all. I'm going to change that to 1 in 10. So I'm going to decimate the data. I'm going to read in only 1/10 of the data for my default region. Now I'm going to add a corridor. And I'm going to select the existing road and make a 100-meter wide corridor from that data, or from that road. Now I'm going to create another region, which is a polygon. And I've got 2 polygons. I'll do one at a time. They're both called AOI for Area of Interest. Notice that when you select a polygon, you can do interior or exterior. I want the interior. And let's just do one more here. AOI2. So now in my Selection tab, I have 4 regions. The region is only reading 1 in 10 points. The first 3 regions are set to default, read them all. In other words, skip 0. Okay, let's read it in. This takes a little bit longer than reading the files without regions and polygons, but not a lot longer. And you'll see when it's finished reading them in, that we have, first of all, we would expect 3 million or so points if we read in every single point out of the files, because there's about 1.5 million per tile. But in fact, we'll get less than that. So you can see that it's read in all the data, and you can right away see my areas of interest are darker. There's more points than outside the areas of interest. Let's just zoom in a little bit here so you can see that more clearly. So this roadway here is my corridor, and that's 100 meters wide there. Let's double check that. I actually can't remember whether it's 100 meters each side or 100 meters wide. 100 meters wide, so 50 meters each side of the corridor center line, 100-meter wide swath. And then, of course, the polygon is just denser on the inside. So out here, outside my areas of interest, we're skipping 9 out of 10 points. In here, in my area of interest, we're getting full LiDAR density, and there are only 800,000 points in here, quite a bit less than the 3 million that we would have got if we hadn't done the selection. Just to emphasize, there's no problem with reading in 3 million points. 30 million could have been a problem, so that's why you need this selection tool. Let's take a look at the LiDAR data. I'm going to get rid of that background for now. I don't want to see it. Now, I'm in the area of interest, and yet you're still seeing some dense areas and not so dense areas. LiDAR is a laser device that scatters off the ground, and you can see areas where there are openings showing up as dense points. There are obviously near the road. There are no trees, and you get a lot of scatter from the ground. And if you look closely, you can actually see scan lines in the data. And then away from the road, where there are trees, the points aren't so dense. In fact, this area right here must be particularly dense forest because the points are not very close to each other. In fact, there's a distance between those points there, measure tool, of about 11 meters. So people may tell you that you're getting LiDAR data that's 1 point per meter squared. Depends on the foliage. And watch out, because sometimes you're going to get a LiDAR file from a provider that is actually looks like a grid. The points are sitting on 1 meter even spacing. What they've done is they've made a surface, which I can do here very quickly, and they've just laid a grid over top of it and sampled the surface. So you lose the information that I can see here, which is where are the points dense and where are the points not so dense? Where am I missing data? Anyway, let's create a surface here. Now the nice thing about the method that I use, now I don't need to look at these LiDAR points anymore, so I'll just deselect them and they'll disappear. The nice thing about using the selection method that gives you all the data but thinned where you're not using it is that you get contours everywhere. So you can see the context. Now if we look closely here, I've got a couple of these orange symbols that represent places I'd like roads to go. So I'm going to start by planning a road from this point here to that point over there. Now I've created a surface, and I can actually drape a feature on here and see what the profile looks like. So let's peg a road from here to there. Now road pegging traditionally was done on contour maps with a pair of dividers. Now you can do it in software. The terrain module is great for this. And I'm just going to read in a screen layout that has that in it, pegging. Okay. It doesn't look very different. But there's some different stuff in the status window here that's going to help me with this. So I'm going to create a new road feature. Call it Spur 1. I want it to be a draped feature, so I turn elevation off and leave modeled on. I'm going to draw it with the mouse. And I'll just create my first point and click it down where I want the road to start. About there. And then I'll create another point and click it down here. Notice that in my data window here, I've got an average slope of -6%. If I pick that up and move it down a contour, oh, it's now -15%. I'm getting some nice information. I'm getting information about the length. It's 54 meters from the previous point, and the slope. Well, that's nice. How about the profile? What's the profile look like? So I'm going to create a new window, profile, and let's tile these. Now, of course, this would work a lot better if I had a bigger monitor. In fact, I do have a great big monitor, but we're only looking at a tiny screen because I'm sending it over the internet.